Hello. How was everyone today? Can you hear me? Okay, good.
Yeah, everything's fine.
All right. Good. So great. Let's see. Okay, Amanda won't be able to talk, but you'll have to disconnect and rejoin. Okay. No updates. And she'll have more to tell us at the next Cognition Futures meeting. That's great. Thank you, Amanda. All right. So that's so I guess we can go around and do updates. If people have anything they want to share. I know Amanda already updated us. How are you, Jesse?
Oh, good. I was just trying to finish something up in the notes page. But it won't quite work how I want it to, but that's okay.
All right.
I'll put the link here.
All right.
As usual, people are encouraged to, take notes. Add things to the open notes document. I have a bunch of different updates. I don't know. Sounds like nobody else wanted to say things, but there's a lot of things that have happened this week. A lot of stuff has been moving forward and crystallizing. I think there's sort of like my updates, and there's like lab. I was talking as Jesse, and then putting on the lab admin hat, and talking about everything that we've done. I'll just do the former. But it's been a busy week. There's been a lot of different meetings that have happened this week. There's been some new people coming into the lab through the lab. I've spent a lot of time. My general update is I am deep within the I don't know, midst of it, throes, whatever you want to say, but like planning and planning and organizing and developing ways for people to contribute to different research strategies. It's kind of been my week on many fronts. So I'll just put, well, the last few weeks, but like I have, I'll just share this. I just put this, I'll just share the links we get on all of this stuff. This isn't quite set up. Ooh, I don't like how some of this is displaying now, but that's okay. It's all right. I'll fix the formatting of it later. That's way too big. But basically, I had this conversation in. I just put this in like the professional development chat, and well, it's not quite the one I wanted, but that's okay. Suffice to being, I feel like I'm in on many different levels. I'm doing a lot in terms of just setting up a bunch of things. I spent a lot of time in Notion this week. I spent a lot of time talking to people. I found some new ways to use, like I'm using LinkedIn for certain things that I haven't done before, and set up stuff with New York Celebration of Learning Computing. And it's just there's a lot of new stuff, and to kind of be more concrete and clear in my speaking for now. We can go through. Like all the stuff is on the docket, but like we can go through all this stuff. And yeah, I guess before I go into some of the other specifics in the lab, I would ask what you wanted to talk about, or if there's any other presentations you wanted to make today, because we'll obviously center those things. So other presentations you want to make, let me know, or let us know now, or like anything you wanted to particularly hit, Bradley. I know you have your project management course.
Yeah. Does anyone, Hussain or Raj, do you want to present something today, or you want to talk about anything before we move on? Okay.
Okay, cool. Also, special shout out to a lot of the interns who've been passing through and stopping by and showing interest and coming to some of our meetings. And a few people have met about Google Summer of Code. That formal application period doesn't start until later in March, but we have a lot of strong interest now, and a lot of it looks like it'll be a promising summer. And just to reiterate, for anyone who doesn't get quote unquote officially accepted by Google Summer of Code, you are welcome to join our cohort, basically, if you want to work on the project through summer. We've had someone come in, we had a discussion this week with someone who really wants to do work in some areas around Google Summer of Code, and we happen to also have a pretty good opportunity to help them get academic credit through their home university. And there are ways we can try to help folks who are coming through. And I imagine, like I'm saying this specifically for a lot of the potential interns or people checking this video out like retroactively, like just to really designate and highlight that you will have a pretty good chance of both working with us in general, if you have if your proposals and what you want to do is in line with what we're doing. But also, now is a really good time to be, if you're thinking if you want to do stuff during the summer and get academic credit for it, now's a great time to start that process. If you're at UAlbany, which a lot of our interns have been through that specific program, please reach out to me or Bradley and let us know. We can start the dialogue soon with your department or with Casey at the Undergraduate Center for Research, Kersey, basically. So just a specific shout out to that.
I have a question. So we've been intaking a number of interns, and I don't know how many people are actually trying to do it for credit versus not. Most of the people we've talked to, I think, have said that they're not trying to do it for credit, or at least not this term. So are we keeping track of that? And I just want to make sure that if they want to do it for credit, that they're getting, what they need in place.
Pretty much everybody, with exception to, kind of Brian's done things in a certain way and definitely Brian has gotten credit through the course directly. Like they completed the course. The majority of people have chosen not to do it through university credit. And I think a lot of the folks who've done it are just very ambitious in terms of the credits they're taking at the time.
Yeah.
And so for them, it was actually easier not to go through that route. But all of those who have sought for or arranged coursework around it or things like that have so far. It's just the majority of them have not for different reasons. Some has to do with the time they join. And that's kind of why I'm saying this, like, yeah, now is a great time to think about summer, so get all the ducks lined up now. But some of it has to do with time they join, but a lot of it is just people like Sam and Sadhna, and I think everybody who joined in the spring 2002 cohort
22
or late summer cohort did not choose academic credit outright. So it hasn't been a lot, but
Yeah.
it has been successful when it has been asked for, or has been arranged at least through coursework so far.
Yeah. I just want to make sure that we're not missing people, like that they need credit and they're not getting what they need.
Absolutely, and if that's an issue for anyone, please reach out. Absolutely.
Yeah, I think building it around that's what I always did when I was an undergraduate. I always built like my credits as like a thing that, things were synergistic. So like, you take courses that went together. And so something like this would be like independent study, but you'd want to make it relevant to what you're doing now, not just your degree program, but like, follows through from other things you're doing that semester. So yeah.
One thing, like particularly for I can mostly speak about UAlbany because my experience is there. There's actually, it depends on the school, and that's why it's hard to really generalize this. But there actually are options to basically do independent study. And I think that's one thing that a lot of like younger early career folks don't get, is that if you go to a professor who has the time, and the real talk, there are some people at all levels of academia who don't give a care about you or want to invest in you. And it doesn't matter what you do with them. So let's hold aside that. But for a lot of folks, a lot of professors who have time, particularly if they're more established and benevolent, especially, rather than maybe some of the younger adjuncts and people who are like super don't have time. But even a lot of them honestly have responded well to this for me and others. If you go to a professor and say, hey, I really want to do this research, here's my project outline, I've considered it this way and discussed it. A lot of them are like, oh wow, that's great. And there are kind of ways to, if you have interest and enthusiasm in something, you can get a lot. And there, like, I would say to anyone who's new to the lab or new to research and kind of checking this out for the first time, we and the lab are probably an amazing first set of people to ask about anything about this, and that we will help you talk to your professor if you want to. So you can talk to them saying, hey, I want to do this. Could you sponsor me? Because a lot of times, sometimes you'll need a faculty sponsor to get academic credit. Not always. And UAlbany, they have it set up so we're doing like experiential learning. So the lab is basically the host for an experiential learning session. And then the lab's fine. Sometimes you need, especially for like grants, or like the CURSE funding, the undergraduate research grants that I've got a couple of. I think Brian applied to some too. Like you may need a direct faculty sponsor, but there are ways to do that. And I think kind of if you have a long-term sort of career in research, like learning how to do the funding, learning how to kind of present yourself, like that's sort of like the deeper, like, this is such an anachronistic term now, the inside baseball.
Yeah.
of like research life, is like, how do you do like to deal with like the interdepartmental politics and funding needs, and how do you present your work to make it relevant? Like we don't talk. If you're fresh to research and just like, what are we talking about? Like, don't worry about it. You'll find out if you want to go down that path. But if you do, like, this is a very open place to talk about all of the stuff that goes into it. So
yeah, looks like Amanda said she wants to introduce herself to the new interns. Mm-hmm. She'll send it to the Slack as well, so she's got a nice write-up of her interests here. So she has a master's in philosophy. She's working in the Cognition Futures Reading Group, and then she met Jesse through a CogSci reading group hosted by our graduate program. Then she taught college for a while in philosophy for a few years. She's now a research assistant in a lab that studies anesthetics and psychedelics in the rat model using EEG. She studied cognitive science and philosophy in undergrad, and primarily interested in how philosophy of mind can and should influence the scientific study of the brain. So that's great. Maybe we'll post that somewhere.
Yeah, it's just an excellent example of how
Yeah.
to explain your background and your interests to new people as an academic.
Yeah, maybe we should do, like, Jesse and myself should do that. Like, all the people who are, maybe want to take on interns can do that, and then we can have like a set of profiles so they know, like, people who they can.
Yeah, an actual
Yeah,
about me lab page would be something
yeah,
with descriptions. We have one, but not like with no words. No
right.
real driving going on.
Yeah.
Yeah. I'm gonna copy and paste that
Yeah.
into the Notion page.
Mhm.
Okay. So there's a whole lot for me to dive into. I don't know what you'd like to start with, Bradley. Here's kind of
Well,
our
yeah, we need to go over this. I'd like to talk about the project management course, and I have some features that I want to talk about as well, and then papers at the end. But we want to spend some time on, I think, this task board, and, like, especially the abstract for the EI workshop that we talked about, and Alife if you're interested. But we'll get to that.
yeah. Yes, more about
Right.
life writing. Yeah.
All right, so I guess I'll do the project management thing now.
Okay.
Can I share my screen here? Apparently, multiple people can share their screen in Jitsi.
I think it's like layered. Yeah. It's
Yeah.
kind of goofy.
Where am I here? Okay, here it is. So we had this week was the sort of the beginning of Unit 3 for the project management course. So, Unit 1 was working open, Unit 2 was on community building, and this is on, I guess you could call it discussions, documentation, and events, public events. So this is on discussions and documentation this first week, and then next week we'll talk about public events. So last time in community building, I put under that heading, I put this idea of technical debt. So if you came to the meeting last week, you saw the slides on technical debt, including the memes that people made on technical debt. So I highlighted the thing that I'm not necessarily proud of, but it's our DevoLearn repository, or our DevoLearn organization. And then within that, the DevoLearn repository, the DevoGraph repository. I pointed this out to people because it's a source of, although we've been trying to build it, we only have certain times a year where we really focus on it. So that would be over the summer with Google Summer of Code, and then during different parts of the year when people get to what they want to do with it. So as a result, we've incurred a fair amount of technical debt. And some of it's unavoidable. Like, you build a resource, and unless you are monitoring it, like, on a weekly basis and using it on a weekly basis, it's almost impossible to avoid incurring technical debt. But we've incurred a lot of technical debt with DevoLearn for a number of reasons, changes in versions of Python, different toolboxes going in and out of service in different ways. And so that's one of the things I wanted to point out. I wanted to give people a concrete example of, the types of technical debt you can incur. And then, of course, another problem is that our release schedule is out of sync. So, we get to release things when we hit a milestone in the project. And so we haven't really made a release since February of 21 on PyP. Well, we've actually, you can still clone say, the DevoLearn repository and run it with probably some of the latest updates. So, all these things are kind of contributing to technical debt, and it's really, even people know what they're doing. I don't know if I know what I'm doing really, but will incur this cost, and it's just a fact of life. So just being aware of it is not enough, apparently, but it's something you have to think about and consider, and it has to be in part of the project management scheme. So this was discussions, documentation, and public events. And so the first topic was how to develop desirable, useful, and sustainable discussion forums. So we have our Slack in the lab here, and this is one of the things that you want to cultivate, not just, dump people into a channel and have them talk. You want to cultivate discussion. You want to do certain activities to keep people, coming back. You want to also have, things that are useful for further action items. So one of the things I pointed out was that when I worked in the Rockware initiative, we had these two streams of discussion leaders. So this is a type of participation. This is shaping discussion. This is where you have, the first thing is to use a feedback board, to take ideas, to put them on a feedback board, to give them upvotes or downvotes. From that, idea being posted and the feedback, you can moderate the board so that you can take the best ideas, promote them to GitHub issues, interact further with like a code owner or someone who manages a repo, and then turn that into a successful code-related contribution. Then the second path is through something like Slack or Discord, where you can make general announcements of special events or other things. You moderate that discussion so that it flows, that bad actors are thrown out or minimized. And then, you can, from that curated discussion, you can create issues. So if you're moderating it and you see a thing that needs to come out and be made into an issue so it doesn't get lost in the stream of things, then you can do that, where you can create discussion board ideas which can go back up to this first stream. So this is one of the ways in which I've thought about this in my own work. And this is, an example of, in a community where you have a goal of getting people from just kind of onboarding to doing something. And discussion can be an important part of that. So these are feedback boards. This is using GitHub. So in GitHub, in a repository, you have a discussion board. This can serve as a feedback board where you can upvote and downvote things. And the great thing about using GitHub is that you can just turn things from these discussions automatically into issues and pull requests if need be. So it interfaces directly with GitHub. You have question and answer functionality, polls, and everything's divided into these discussion threads where you can put an idea in there and then get an upvote or downvote accordingly. So it just gives you like these chunks of ideas and chunks of feedback, and then you can use that to shape further discussion. And it puts it all sort of in that digital, it gives it a digital trace. So there are a number of different ways you can use feedback boards. Different organizations have used them for different things, for answering questions after a major release, getting feature requests, working on core systems in your project, building what they call ordered timelines for media, and other phases of development. So NASA and Pixar are actually interesting because I didn't know that they did a lot of open source, but apparently they do. So this is, shows the diversity of these types of things, how people use them. You don't have to use them any one way. In Agile, people use these feedback loops. So these are actually, if you go back to the discussion board example, you're working from like an idea and you're shaping the discussion on it, and then you're turning it into a concept. And in Agile, you have these feedback loops. So you want to close the loop, as we like to say, on some of these ideas. And so, bringing it back to sort of that original idea, how do you do that? And so, in Agile, you have these loops where you start from a starting point, you accomplish some coding task, and then you go back to the original idea through unit tests and pairing. You do a sprint demo, you start from zero, you do a sprint demo, then you get feedback from product owners and stakeholders. And then, like in a release, you go from zero to a release and you get feedback from real users through metrics. So there's all these feedback loops in these streams of discussion, streams of development that kind of intersect and give us some things. So in Agile, there's a 4-step feedback loop. You can capture and store the input. You can analyze the input, make decisions based on the insights gained from the second stage, and then the implementation of changes have been set forward. So these 4 things are kind of like, if I take a discussion, I start with like an idea and I polish it. It's not just a linear process, it's actually a feedback loop where, the feedback that you're getting informs the original idea and you end up with this polished product at the end. And then something you wouldn't have expected from the starting point. So the next thing is integrating discussions with community events. So this is an example of something that we did in the Rockwire initiative, where we had hosted a speaker on mobile app design, where he was like, this is a space where there's very little expertise, and we needed to find expertise so we could bring it to the fore and educate our contributors and our developers. So this person, he's done a lot of development with the Ohio State app. So Ohio State has a really developed campus app. And, you're either in the world of campus apps, you're either building your own and you're investing a lot of development time and effort into it, or you're just basically taking some solution off the shelf, or you're homebrewing something that's really bad. So we want to avoid the latter two. We want to embrace the first, but to do that, you need to think through and you need to pick people's brains about what are the best ways forward in terms of design, in terms of some of these other things. And so this was something we cultivated a discussion on this. We hosted a speaker, we had the video on YouTube, and then I developed a Substack post where a lot of these design principles were extracted from the video, from the materials that this person provided. So, this was a campus app design principles write-up where we talked about some of these principles, like doing a few things well, reducing friction, so forth, and then giving examples of that. And so this would help facilitate some of these discussions where you come up with an idea, but it's not just any idea that you have out there. It's informed by something like this, where you say, how are people doing it that's really effective? And then, you have that as sort of a mental model, and then you can craft your idea so you're starting out at a higher point. So this is, again, the monthly. So this is a Substack post, kind of incorporating that. And then I talked about stream feed integrations, which is this idea where you have multiple feeds like we do in our group. We have our, YouTube channel. We have our Twitter feed for now. I don't know. When we have Slack. So we have all these different feeds and there are different things in them. And the idea is to integrate all of these into one sort of digestible unit, or, a space where we can interact with all these simultaneously. So we can find insights, synergies, and pull things out. So this has to do with the flows of contributor and development activity and the flow of media that enables access to short and long-term information. So, we can use this idea of streams and feeds from social media or from, these interfaces that people have where information is either curated or it just exists in the stream where it's coming up from different posts. So we can actually integrate these two things. And this is an experiment I did on our website about a year and a half ago, where we had these different feeds that were all kind of put together in one place. So we have our Medium, we have our stream of tweets from our lab account, we have a Slack channel, and then like a public Slack channel that we had, and then the YouTube channel. So these things are all kind of can be integrated in different ways. And so you can see like what's going on in Slack versus the Medium. So these are different time scales of thinking. Slack is sort of, just kind of flow stream of consciousness. Medium is more polished content. YouTube videos are maybe even more polished content, or they're, things that we're doing, where we're presenting. So there are different scales of, time scales and different scales of what we want to do. And so, having those in proximity and kind of sifting through those in different ways is interesting. So the next thing is curated discussion channels to support community. So making discussion sustainable. You want to make your discussion forums sustainable so that people don't leave, or people don't, people can actually get through them. So with stream feeds, we have all these different feeds we can maybe sort through them in a way that's serendipitous. We might find new connections, but we also want to make these discussions sustainable so that they don't, get congested with things, or that we can actually parse out different threads. And so that's kind of, there are two models to this. The first is the Slack Discord model. So we're all familiar with this, but there's a lot of interesting sort of detail to this. If you think about if you're curating a Slack or a Discord, it's a different level. So you want to get people to come in. You want to get them in the door. You want to publicize how to get in. You want to be able to use file sharing, chat, and private groups as appropriate. You want to join a channel to become part of a conversation. You can tag people to bring them into the channel. So channels are important, and managing like who's in the channel, who's seeing what is important. There are benefits and drawbacks of something like Slack. You can make things private with respect to the internet, so not everyone can get in, and but so you can focus it to certain people, but you also, maybe you don't have the right people in the channel. It should be easy to navigate. You can get feedback and manage content. You can directly answer questions in the thread of discussion. But one of the problems with Slack and Discord is, of course, message avalanches, or that you a lot of times get too many messages per unit of attention. If you're in multiple channels, for example, you're going to have a lot of messages, maybe, and you're not going to be able to get through all those messages. There's no native way in Slack or Discord to sort those out and prioritize them. So this is a problem. But fortunately, you can do things like do channel reviews that tie into your community activities. We've done this in the Saturday meeting, and that works sometimes to bring people's attention to certain things. There's also this idea of a stand-up. We've done the Slack bots, where we'd ask people, what are you doing this week? What are you going to do next week? And so forth. So there's strategies for that. Slack originally, when it came out in the early 2010s, solved this problem of email threads where people lack control of the conversation flow. So people sent email threads, and there, a lot of problems with that model. And so Slack really kind of undid that Gordian knot, but it has its own problems. So there are a lot of best practices for Slack and Discord. One of the lessons is to automate things and to sort of organize them. And this brings us to bots, which I talked about. And I made them aware of bots, where there are different types of bots you can use to manage information. And you can automate things, and there's a whole economics to automation. And it's basically that there's this zero-sum game where, is there an incentive to build a bot to use it to automate something? If you're using it on social media, does everyone use it or just you? Same thing internally to Slack. Are you the only one using a bot, or is everyone using a bot? And that's I talked about this. I'm not going to get into this, but if you're interested, let me know. It's an interesting take on this. But anyways, so then there's the discourse model. And discourse is it's a different type of sort of chat forum that you have to install on a server. and you can customize it in many ways, and it's broken up into these discussion fora. But there's an interesting aspect of discourse that is unique from Slack or Discord, and that is that you can have these badges or these sort of rewards for basic competencies. So if I, have a first one box badge, which is where you, put up a profile, you get a badge. So you get some sort of participatory award. And then that builds upon itself so that you have these different types of levels of involvement or engagement, and you can build on that. So, there's discourse has a high visibility, so the discussions are highly visible in the interface. It's nice looking, uses Markdown for threads instead of text. And then if you have 1,000 users, who's most active and how could you best leverage their efforts? So for the most active community members, you want to keep them going, so you want to incentivize them for their efforts. But you also have less active community members, which are actually a majority of people. How do you incentivize those people to become more active? So you want to maximize everyone's involvement. And discourse does this through this user trust levels idea, where if you do something, you get rewarded. If you do something a lot, you get rewarded. And there are these patterns of interaction that they reward. So to become a member, you need to visit on at least 15 days, not sequentially, cast or receive at least one like, reply to at least 3 different topics, enter at least 20 topics, and the like. And so they use this as a way, they reward this formally through badges and other types of things. And they give you a member status. So it gives you a higher level of involvement. So it's really kind of an interesting way to cultivate discussion to make sure people are really engaged. And so compared that with Wikipedia, where they do a similar thing with editors. Then I talked about minimal viable community, which is what is the smallest group of people you need to support your programs. And there are a lot of ways you can implement a minimal viable community with respect to these discussions. So then I wanted to talk about lecture 12. Actually, let me see. I think we had a couple of comments. Okay, so Hussain said, our lab here at the University of Toronto has used the Agile Scrum methodology even with research. It's been successful. Yeah. I think that's interesting. Yeah, people are adopting that. I think like Neuromatch and it's interesting. This next lecture, I'm going to touch on Agile, and in this course, I'm trying to. I haven't really hit Agile head on, and it's a great method, but there are some drawbacks actually, and there's some criticisms of it, which I'll get to in subsequent lectures down the road here. Like this idea, there are a number of things that make it really effective, and there's some things that make it ineffective, and it's kind of interesting how it's diffusing outside of tech. Maybe what aspects are people retaining?
Yeah, like for sprints, for example, as part of the Agile Scrum methodology, we would have these coding sessions and these parts of these like mini hackathon type things. So yeah, there is criticism of it definitely, and there are ways you can draw its disadvantages, and it has those things, right? Like for one thing, I think parts of it can come across as a bit too structured, like a bit too methodological at times. But yeah, we even used it with like publishing manuscripts and getting the actual research done for papers. So yeah.
Yeah, that's great. Yeah, thanks for that. So yeah, lecture 12. Then we moved on to documentation. And so documentation is kind of a boring topic, but before I did this, I backed up and talked about the history of agile methods. This is what Hussain was getting at with some of the agile methods adopted for academia. But where we were before agile was this thing called waterfall, where you would have like these very distinct stages of development, concept, design, development, and test. And then as opposed to agile, where you're doing this iterative testing, you're doing design and development, and in between there is the testing phase, where you're trying new things out. So it's this very iterative process. It's made for what, the term that they like to use at Facebook, moving fast and breaking things. That comes from the agile methodology. So you break every task down to its smallest units. You get things done fast. You get frequent updates, and you change direction on demand. So we talked about bot updates through bots, chat bots. That's one example of that. Just keeping in constant conversation with your collaborators. So in around 1970, waterfall was proposed, and this requires much documentation up front, and it development has to happen after you have all your docs in place. So your docs are almost like a architecture or like blueprints for what you want to do, and that's there are advantages to that, but it's slow, and it doesn't necessarily give you the best technical outcome. It just basically specifies everything. But of course, if you run into problems, that's an issue. Around 2000, people saw the shortcomings of that and founded Agile. The Agile Manifesto is listed here, and you can see that Agile is very different. It breaks problems into digestible components, and the documentation is secondary. So they're big believers in lean documentation, which is where you use verbal communication, meetings, chatbots, and this replaces documentation, at least from the standpoint of serving as a blueprint. You still need documentation for describing processes to new people, say, but that's not the focus. So there's this brief history of the Agile method at InfoWorld. That's something, if you want to check that out, that's interesting. This is the waterfall approach, and the point here is to show all the documents needed for every step of development. So you need at least 6 stacks of documents. And I made the point to the students, because they're in their 20s, that back in the 80s or 90s, you would buy a piece of software, and it would come in a big cardboard box, and the actual disks were floppies, which were very thin and not that big. I mean, they were bigger than thumb drive, but you also had these big manuals that came with it, and there were these 200 or 300 pages, and that was all the documentation. So you'd have documentation for everything, detailed instructions, and the documents in the waterfall approach specify the parts. It's top down, it's controlled, and everything has to be in place before development happens. So at each stage you need to specify everything. Now, as you can see, that might be untenable. And in fact, in terms of total effort, the traditional method, the waterfall method, requires a huge amount of effort up front to put all this in place. Whereas in Agile, you don't really do that. You start with a vision, and then you move out to the end point where at which point you put together the docs from your notes, from your trial and error, and you build that. So it's less effort overall. It's less effort up front. Then, their core practices for Agile, lean documentation. You want to be efficient, you want to be public, and you want to keep documentation just simple enough, but not too simple, which is easier said than done, I think. And then they're different, again, this is update only when it hurts, which means different things to different people. Sometimes people don't feel the pain until things collapse. Other times people feel the pain every time there's a bad issue that comes up. So, it depends on the team you're working on. It's not always going, that sort of linguistic advice, can be very different for different groups. Then you want to be able to build different types of documentation useful to your community or organization. So I gave people some readings here. So there are a number of readings. I'll put these in the Discord for the educational Discord we have, if you're interested in the slides, or I'll make them available if you're interested in specific lectures. So there's some background readings here. 5 tips for making documentation. And this is again stuff that is making it consistent with the project. And I like this idea of valuing contributions to documentation just as much as code. So if you want people to write documentation that's high level or good, instead of just kind of like, here's this, this, and this, then you want to value it in your community. So there are all sorts of documents that you can make. You can make very simple descriptive things, or you can kind of focus on the whys. So, you have like the README file, install instructions, maybe a hypothetical, why would I use this product? And then maybe like a cookbook, like how-tos, and then things like blog posts, which answer larger why questions, like why would I use this product, or what's the history of this product? So there's a lot of the documentation ecosystem, as it were, is very complex. We've done this in DevoWorm, where we've had like best practices as documentation in terms of markdown files. So we have different community standards that we have. We don't always follow them, but this is technically what they are. And so we have these documents that have been made. You might also have like a README, but for like a project that has multiple parts. So this is an example from GitHub, where you host this as a markdown file. You can, just show like a roadmap and be descriptive. You can also have like documentation for specific software with example notebooks. So, the level of granularity is important, but it depends on how you're using it. Then you have these platforms like Read the Docs, where you have markdown files, but they're linked together in this sort of menu on the left. So, if you have a project with a lot of different types of documents, you might pick something like Read the Docs. You can go in and build documents that are nested and have them all sort of easy for people to read. Then you can use Notion. So I just kind of pointed to some of our Notion experiments here with, this is a GUI-oriented database. So it's a database underneath, but you can it's easy to manipulate on top. And, it's for internal documents or planning or archival features. And this is our Cognition Futures reading group, where you have this table, just to show what it can do. Coda is kind of similar, but the thing I wanted to point out about Coda is that you have these patterns of use for documentation. So depending on how you structure your documentation, this relates to use patterns. And so your team will organize itself around the docs. And if you have like certain documentation strategies, you're going to have different sort of organizations that emerge. So, you have the user nova, which is two main docs where most of the people are interacting, some side docs where a few people are accessing them. The doc explosion, where you have a lot of docs that are of moderate importance. This is where you get a more dispersed set of interactions. The classroom, where you get these centralized interactions. Squad goals, where you have this more distributed set of clusters, and so on. And so the orange squares are the docs, the blue circles are the users. You can see how they interact. So, this is something else to think about. When you build a documentation ecosystem, what kinds of social patterns do you want to emerge? What kinds of ways is your community already interacting, and so forth. You can also use ZenHub. We've talked to Jesse, made a video on ZenHub. And this is again, where you have these roadmaps and epics. I know at one time Jesse was using ZenHub. I don't know how ZenHub is being used now, but basically you have these timelines and you have these epics, which are in time, but they're also prioritized. So the epics are like GitHub issues, and ZenHub roadmaps are like, timelines that overlap. You have, things going on in parallel, and critically they mark dependencies. So there's a dependency in this timeline and there's a dependency in this timeline that are interconnected. You can't start on this timeline until you resolve this dependency. So they're linked like that. And, just kind of going over this as a concept. Yeah. So then, again, epics. So working with epics interact with GitHub. So the interface, you can plug an set of epics into GitHub, and they look like GitHub issues. except that they have a time component as well. And this is what you do when you organize a Kanban board. You have like a prioritization scheme, so you can sort things into put it on hold. It's high priority, low priority, and so forth. So then there are some further readings on that. And then at a couple more slides on repository cards. I actually did highlight Ankit's repo on Fliscopt and how he uses badges. I like how he uses badges for different things here with open source. Is it maintained? Pull requests are welcomed. These are just basically social signals, and they're easy to implement in Markdown. There's also badges where you can get status on continuous integration, and whether you can run things in a Colab notebook. So there are a lot of pieces of information you can put in badges, and it tells people something about your repository. So it's a form of documentation in that sense. And then finally, that you have these. It's important to remember that you have these different levels of contribution from experts who can deal with things like architectures to no code. People with no expertise who might benefit from something like a no code approach. So Notion is sort of a no code approach to a database. You just enter a command and it pulls up a data structure. But there are other tools for no code. There are OpenAI Codex, Glide, MediBlocks, which is like a flow chart that you turn into code. And then there's also the Turing way, which is the sort of an architecture for documentation. You can do all these high level things like project design, collaboration, communication and outreach, and so forth. So that was all I had for that. And then next week we'll be talking about public events, and that'll be like docathons and hackathons and things like that. So hello, Vrushali, how are you? Looks like we had, and Ankit, of course, is here as well. Okay. Yes, hello.
Yeah, did Ankit or Vrushali want to give any updates? I know or anything else you want to say before we did updates earlier, but I know Bradley just finished I guess the 2 lectures there. Any questions about that? Okay. Anyone else want to chime in or give an update before we move on to other things? Okay.
So I guess we're going to start on the timeline for papers and submissions.
Yeah, I'm pulling that up now. So let's see, how is this actually looking here? Is it better to do it shorter, or does it really matter? Well, we'll do like that for now. Okay, so here's kind of what's on the docket. I'm a little bit envious of Zen Hub's organization, some things there, but maybe we can get to that level in the future.
Yeah.
This is basically a view of this year so far.
Is this in Zen Hub or in
no,
Notion?
this is Notion.
Okay.
This is our I haven't yet put this out, but this is basically database. As you may recall from last, well, I didn't really formally, I guess, demo this too much yet, but I've combined outputs, events, some of our tasks all into one database now, and basically have these are sort of, this is more like the library. It's more like project management land. So you have our meeting notes, which is all of our meetings, which is, I really like this a lot of our meetings here. from Future Future to Saturday Morning NeuroSim, going back to, I kind of limited this a bit, but even the Google Summer of Code meetings from the past, and other like ad hoc meetings. Reference materials are like papers and essays and external resources that we're looking at. I've added a couple. I'll get into those later. People are individuals. There's a lot more to flesh out this database with, but just kind of something you can tag and reference. Glossary and concept library is just terms that we're using and kind of you can make associations with them. Like semiotics came up this week. Dendritic computing was a few weeks ago. Groups and institutions, not really that important. I'll get into that some other time. But this main one right now, this is basically a database where we have a lot of things that are. This is the timeline view, and then I have a list of all of our a list of events. Like these are events we've participated in or wanted to take a deeper dive into. Some of our outputs, like the manuscripts and papers and blogs that we're doing. Incomplete lists, but kind of just to keep track of things we have actually been outputting. This is an event by date timeline. These are some other. This is everything, which all items now includes like actual task objectives and outputs and like event lists. This is basically a lot of stuff here. This is something else I'm working on for later. But in a very short preview, a lot of stuff has been combined into all this, and I kind of sorted this out mostly last week. So it's kind of strange to me because I've been staring at this for about a week, and I think most people are seeing this for the first time. So I've kind of lost like, oh, this is the new part, this is the old part. But having this timeline view, I think, helps a little bit because we kind of prioritize what's been accepted,
Right.
and then things like that. Hold on, sorry. So just to kind of do a really quick review of this, I don't think anything's happening with this one at the time, but that's not even open yet.
Yeah.
So everything else, and kind of like these are the kind of as it stands, these sort of things with these emojis here are kind of like actual events. This is a writing competition, and these are sort of administrative periods. Like we're basically in Google Summer of Code pre-period. There's not really a lot that's basically just people are just, looking at the proposals and talking about them and asking us about things. I should actually probably have this be under change. I'll do that later because I think technically it starts the 20th.
Well, the application period opens on the 20th.
Yeah, let's have this be.
We really have people. Yeah, we really have people coming now. I mean, it's not. We're thinking about it now. So.
Yeah, it's active for all intents and purposes, and then we'll enter the formal period after the 20th. Of like, oh, now you can submit. But like people are obviously thinking about that now. I'm going to get to all these obviously, but just to kind of go through this stuff first, we're doing a lot of updates here. On the admin side of things, we have the kind of defining the Dev AI space a bit more. We've had some discussion on the research banner map. I think this is, we don't have to get into this here necessarily, but we're basically in the process of updating this original map from last year, and we've had some discussion in this Notion page. Can I do this? In this Notion page to kind of, how are we going to fit Dev AI in there? What are we going to swap out? How are things going to work? Bradley kind of explained these sort of different branches of DivaWorm.
Mm-hmm.
and then left some comments here. I haven't followed up on any of this yet, but
Yeah.
it's a good discussion. I think kind of creating a I think combining what I combining what I said here about Dev AI and this, and Bradley's basically suggestion of how to incorporate DevaWorm with all of that is good, because I think that will give some structure to it. For those who weren't around recently, I've had a lot of discussion about kind of reframing cognition futures and the mission statement, and I'm inspired by
I just used yellow. It was just the thing that came up when I was doing it.
Yeah. I'm inspired by Joshua Tenenbaum's talk at AAAI about how he kind of framed his work in cognitive science and being relevant to AI, because I feel like that's something that's a big challenge. As far as I'm concerned, a major challenge in embodied work is like explaining relevancy in a way that's a little specific about different details, or sorry, explaining relevancy in a way that's a little more accessible. So I felt like Josh did a really good job of justifying his interest in studying like some like really key developmental. It's sort of like this getting at some really major questions in cognitive science, but framing it, okay, well, I'm at MIT and I have this big quest for intelligence. There's all this like, we want to build AI tools to verify X, Y, Z. It's like, okay. But that was basically inspirational and motivational to the sense of, I want to continue to evolve cognition futures and kind of the lab in that direction a bit more too, in the sense of like, I don't think there's a good image for it, but in my mind, I kind of see where we're going in the sense of bridging out kind of an interrelation between DevaWorm, Dev AI, representational brains and phenotypes, and then cognition futures is kind of this synergy of research projects. And I think fleshing that out will be good. This year too, I haven't quite done this yet, but I think a goal to get kind of more ready for the summer would be like in neuromatching, there's kind of the matching process for like you're matching with your cohort, but also you're matching with your sort of tracks of interest. I think having some really clear paths of, okay, join the lab, find a research banner or multiple, but like have a start. Basically making sure for intake, for interns or people joining the lab, especially people who join like in between sessions, get them a home base. And we can do like rotations if we want, but like get them a home base of here's your first project, here's your first deliverable, here's your team that you're working with, here's like really clear like involvement in reporting schedules and kind of a path towards, okay, here's your first paper review, lit review, blog post, whatever it is, like the first stage deliverables, particularly for people who are brand new, because those who are like graduate students or postdocs who have also been in the lab or in the lab, like it's a little bit different, whereas they kind of know specifically what they want to do. But other things, having a kind of tutorial, here's your first quest in the lab structure, I think would help out and is much more tenable now. So that's I'll put that here.
So this is like gamification of the whole plot twisters related.
In the most in the most trivial sense. Like I'm not ready to do like, oh, here's your quests and like actually get like points or things like in the simplest terms, yes. But and that will making it actually gamified is an aspirational goal. And I'm happy to do that, but I take a little more effort to do that in a serious way. So yeah, that's what that is. What's on 20 March? I'm not sure how.
The beginning of the application period for Google Summer of Code.
Oh yeah, that's what's.
So where are we with our submissions? We're thinking about the EI workshop. I don't know if Amanda left, but we have. Well, we have I'm going to submit the abstract for the critical periods paper that I've also been working on for Alife. And, we have this other one that we want to do on cognition futures or something like that.
Sorry, my Notion just closed out on me.
Oh.
So. Yeah, that's kind of, I feel like maybe we should start with those submission deadlines soon, just so people who join right away could get a sense of where that is. Yeah. So these are kind of set. This is awaiting for Alife and these two. I know these two are here. What's the actual deadline for these? Do we say is the 10th or something?
I think they've moved it up to the 13th. So they always extend the deadline for it.
Okay.
But yeah.
Did you want to talk about any of these submissions here, Bradley?
Yeah. Let me share my. Well, yeah, I can share my screen.
Actually. Yeah, you can do that.
We can just flip
back and forth. Yeah.
So let me show you a little bit about these. So the first one we're working on is actually just me for now, but this is available for collaboration. This is on critical periods. So it's basically modeling critical periods in an embodied agent. So this is following up on some of the stuff we've been doing with Dev AI. And, we kind of it's kind of also the developmental neural simulation stuff that we worked on with the Brainbird vehicles. It's like laying out, like, how would you implement a critical period in development for an agent? And then how would you, we're also using like Gibsonian information that's coming in from the environment, but also having innates encoded, and then those things interacting and producing an output that you can then, use as like rate of acquisition. So then there's some, methods. There's this plasticity encoding. You have to read through the paper to actually get an appreciation for what's here. But there's some simulation experiments that I've been running. And basically this is what it does, that there's the structure of the connectome in the agent that ranges from, an ordered connectome to a random connectome to this semi-ordered connection matrix that represents, something that happens after the critical period. Then, there are these other simulations where you see the critical period effect after the fact. And then these contingency trees where you have, what we call morphogenetic acquisitions. So that's when the body's being built, you get sensors, you get a connectome put in place. And then these behavioral critical periods, which are if you have like light sensors that emerge, then those light sensors have a critical period of acquisition of light information. So, but those light sensors have to be in place before that can happen. So there's a contingency there. Furthermore, you can't have like connectome tuning without the, those sensors being in place, and then there being maybe a previous critical period for acquisition of information or tuning of those sensors. So, there's a lot more, there are a lot of nested contingencies here that we can think about. So that's one submission. That's very Alife-y. The other one is this open source community sustainability this is a paper on the stuff that we were doing in GSOC last year. And so this is, again, I need to work on this. I also would like to get input from Brian, Hussain, and Himanshu, and Jesse, even if you want to. You were part of the team working on this, and just basically describing what this is. This is basically all these agent-based models talking about how the various efforts that were put into this. So there was the models for collective behavior, which Brian worked on. There was reinforcement learning stuff that Himanshu worked on, and then there's the personality theory stuff that Hussain worked on. And I'm putting these all together in sort of a way that kind of presents these different models as alternative views on like community building or on this sort of collective behavior that we need. And so I guess this is, I guess, getting close to the page limit. It's like 10 pages now, so it can be, and it's not going to be in a different format. So I think the 8-page limit will come out to about 17 pages. So there's a bit more to do on this, but this is for this workshop on agent-based models and artificial life. So that's where we are with those. In the Embodied Intelligence Conference, I want to submit an abstract for the critical periods work, just that abstract, and submit that to the Embodied Intelligence Conference as well. So it's like double dipping, I guess, but it's a different venue and it's going to be a little bit different focus maybe in the slides. But getting that out there will be important. And so that's and then of course the one that we want to do on cognition futures. It'd be nice if we could get those like kind of dovetail. Like I think it was in 21, we did I think it was Jesse and Stefan, who used to be in our group a long time ago, and myself. We all did different versions of talks that were related. So Stefan did a talk on his work on Brainwork vehicles in the Broadgen Brain platform, and I did an overview of developmental AI, and then Jesse did one on I think it was like an early version of the cognition futures work. So we had this nice arc of presentations.
Yes. Yeah, let's well, I don't know. Let's what can we just review a bit? Like what are potential submissions here? You want to do the critical periods one?
Yeah, critical periods.
All right. Was there any other ones that we wanted to mention about that?
I think it's one submission per person. So if someone wanted to submit a abstract, and it's just an abstract for a talk, it's a placeholder. And so if you're interested, you can submit an abstract. We should coordinate on, doing this. So it's like I said, I'd like to have it as like a theme where we can maybe have things that are connected. But this is like 20-minute talk, so you have to put together 20 minutes worth of slides. And it could be on basically embodied cognition or on some of the agent stuff. So if you're interested in agent-based modeling or agent, like something with a body, basically. So it could be robotics. I don't remember who's interested in robotics, but that might be a possibility, or anything with our embodied agents. Yeah, Avery might be interested. Amanda might make her own submission. You? Even you? Yeah. So potential topics are, yeah.
Oops. yeah, let's just Brian also actually might want to do this. I know he's the I think there's a way to combine ethical regulators with this workshop, or that not be as much. I don't know.
The every good regulator,
Ethical
or
or every good, I guess.
well, that brings up a point about the cybernetics stuff. So we could maybe do something with second order cybernetics, or like good regulation or something like that.
I think if Amanda was here, she'd want to be talking about that. So I'll tag her in that. Yes.
I mean, yeah, because I think last year we kind of touched on that. You had like one or two slides, I think, where we did like a feedback thing, and it was like just one slide, so it was a teaser. And another area too of embodiment is in virtual reality. And if it's like something that it's not making models necessarily, but it's also there are a lot of issues of embodiment that come up in interacting with the models. So if that's something that people, I know Vrushali mentioned that she wanted to write a blog post at some point on some topic, and we talked about like haptics and something else. I can't remember exactly. And she gave a huge list of things, and then there are a lot of things that are of interest. But one of them, of course, is embodiment, where you're dealing with haptics, you're dealing with feedback, proprioceptive feedback, multisensory feedback, and so there are a lot of issues there that are really interesting.
There's a lot of topics that are actually floating around, a lot of discussions in the lab. Like there's still a lot of things that have been adjacent to or discussed in some of the reading groups and creation groups too. In that like we're starting to,
Yeah, sorry. So Jesse, are you asking who might be interested in just giving a talk on for the International Conference on Embodied Intelligence? Like would you want to look for people to write up their own like entire manuscripts for this, or just maybe giving like a summary, if like a review or like an overview of certain stuff?
Well, that question is perhaps answered by everything at this conference is like a short talk. Like it's just a bunch of presentations. People want to write manuscripts, they can. But just to kind of reiterate, so each person can listen at one thing, but we tend to break it down, and like we have a bunch of different topics in the lab. So it like we're all typically co-authors of them. It's not initially exclusive. It's just who wants to, and I don't think there's any like fees or anything either.
No.
So it's basically, logistically speaking, it's who are we going to get who's going to submit something or wants to be a part of that. Like I'm probably going to work with Avery to do something with their stuff. But this call for submitters is basically, would you want to fill out the form and apply? Like we collectively we are like going to create the abstracts, I believe, and work on the projects that were accepted.
Yeah. So the way it works is usually it's like about a 200-word abstract, so it's not much, and then it's like a 20-minute talk that you're on the hook for. So it's like, if you have like maybe about 20 slides, which is 20 minutes on the topic, that would work. And then you'd present that, and then they offer you the opportunity to publish a paper in their workshop proceedings. So it's not required, but you can. And so that's usually like about 10 to 15 pages. And by the way, we got our last year's submission accepted for the conference proceedings for
And is this is all virtual? Is that right?
Yes, it's a virtual
Yeah.
conference, so it
Okay.
would be just doing like a virtual talk through Zoom, or you can even record it. So
They have an in-person component for like sloth robotics in Singapore, but I don't think any of us should be going into that. But this event, the conference itself is virtual and has been and will be.
so it looks like Amanda's back.
Great. And then we finished all the referencing Amanda.
Yeah.
But
Sorry for the bad timing.
no, it's fine. We were talking about the International Conference on Embodied Intelligence and sorting through. I don't know if you were with us.
I guess I could be potentially interested in giving a topic, or giving a talk on perhaps even content similar to what I submitted in my manuscript, like realism in the virtual world.
Yeah.
So if you want to put that down for like realism, or
Yeah, I think there's some interesting issues with embodiment and realism, like I think stuff like the rubber hand illusion, where you have like a body versus like something that isn't a body, or a body versus an avatar.
Yeah, not just for those of you who are new to the lab, I've done some writing on David Chalmers' recent book. So David Chalmers is the Australian philosopher who is best known, or maybe not even like best known, but he's known for the hard problem of consciousness, which he formulated a long time ago. And of course, all of his research in philosophy on various topics and stuff. And he wrote a book a couple years ago called Reality Plus, and I've done quite a bit of writing on that book as it relates to science, to research, as well as just for other avenues and things. So that's kind of one thing that I've been doing a bit of research and writing into realism, virtual worlds, basically like the self and reality. So yeah, if you'd like to put me down, I might be interested in giving a talk on the Embodied Intelligence Conference on realism in the virtual world. So
yeah, I mean, it's basically just for other people in the lab, like how this will work is if anybody wants to, like Hussain just has an idea, and that's great, and then it's like what will determine that happening is if there's no like really gatekeeping about it, in the sense of like if you want to do that, like you can put it in this link or not, but it'd be great if you eventually put it in Notion. But like basically the next step for anybody, and use Hussain as an example, would be like, okay, start drafting like your idea or bullet points into an abstract, and then show us the abstract, that we can help think about the abstract.
And when is the deadline again?
They didn't really give us a hard deadline, but basically a couple weeks, I think.
The event is in late March, right?
Yeah, let's.
Yeah, the event is online in March 22nd to the 24th.
Yeah. So probably like March 10th would be like, because it need to have time to like schedule everything. So the deadline, probably you just do it with the registration, I think. So you just in your registration you put the abstract.
Okay.
Yeah, let's give ourselves a working deadline of March 10th. Does that sound fair? Because their website is a little. Yeah. So anyway, many academic websites, including many of mine, are not the most clear. So. Cool. So Amanda, that's great, and yeah, please keep us. I'm happy to see that. I would maybe be interested in fleshing that out. Hussein's idea, and Amanda just returned. So I was thinking, I don't know if you've been, were you here last year for this, Amanda, or not? But I'll put this. I should put this in the slide, just so people can see the event. I was getting to sort of a lot of things that come up in that are sort of adjacent to embodiment. Like I was thinking for Amanda, we talked a little bit about second order cybernetics, but also a lot of the affectivity stuff, like how Fuchs is getting into affectivity, the role between affectivity and like first person, I don't know, awareness or some aspects of phenomenology. Like there could be a specific topic about that, which might be great to look into, and we could probably put up something together about that. And again, like just so people know, like for those who are considering this, or if there's an intern or something, like it's not like it's on you just to make something. We can collaboratively help and flesh out things. So if someone's new to the lab and thinks, oh, I would like to work on something about like haptics, as Vrushali mentioned, like okay, we can work with you to build that out. I'll put that one here too. But yeah, I don't know if Amanda, you had any thoughts about this conference, or if you'd want to do maybe last year it was a thing where like we had some like proposals, we had some abstracts developed in the lab, and then I think Amanda, you might have just submitted one like for the team or something. I don't remember.
I don't remember submitting anything last year. I don't remember. But maybe so I was thinking for this that something with the methods project would be good, specifically looking at how Varela's idea of mutually informed constraint could be put into practice. But maybe the interoception meets Fuchs conversation we were having at the last Cognition Futures meeting could be good. Like investigating interoception and affectivity as a area where neurophenomenology can be put into practice, like the dialogue between first person and third person. I can gather my thoughts on that and say more at the next Cognition Futures meeting. But that, yeah. I mean, I hear the words embodied intelligence, and that is like the first thing to come to mind. Literally, like an intelligence regarding your body. Yeah, I'll think more about that.
Let's discuss that at the Cognition Futures meeting too, because I think like in reality, I feel like we could probably have easily 2, 3, 4, 5 submissions straight out of Cognition Futures, straight out of Compton, and straight out of Cognition Futures in general. Because like there's so many different aspects. Like I think I really want to do just straight up methods project, because I think it would be a really great place to get feedback about methods from like other people's fields. So I think like the goal is just to put this here, get feedback from other disciplines, right? That's what that project is going to be about. But like actually putting some other things forward about like phenomenology, Fuchs, neurophenomenology, activity, and interoception. Even having like a deeper, I would almost kind of love to have a deeper dive. Like classical texts, like Maurice, who's come up a lot recently, Edmund Purcell, like having something that references explicitly some of the older concepts, like second order cybernetics.
Is that what you consider classical? When you say classical, I was thinking you're referring to the classics like Greek or Roman, but that too.
No, that's not what I meant here.
Okay. No, there are Kantian influences in modern day notions of cybernetics and cybernetic idealism. So Kant is worth mentioning too.
Yeah. So having something that's focused specifically on some of the older stuff might be good too. But there's so many, like it's going to kind of depend a little bit on who wants to put some of that together, so we do have a shorter deadline. I do think, like, for sure, these are definite. These two are definitely happening. Whoops. And then these are sort of potentials.
Yeah.
So it's kind of that mix of like, you know, who and what is going to emerge in the next couple of weeks. But if anybody wants to work on any of these, let us know and we can start fleshing that out, because that's sort of a something that we need to start moving on, basically. So
I mean, I also wouldn't mind, like I mentioned my interest was in realism and VR, but you can also put me down if you want for some of the more classical stuff too. I'm not familiar with Merleau-Ponty, but I've done some work and I've done a bit of writing actually a while ago on the Kantian roots of cybernetic idealism, for example. So that would definitely be also another philosophical take. So
okay, cool. We'll put you in that space also. Oops. Great. So yeah, looks like we could potentially get 2, 3, 4, 5 plus submissions, and we have like 1, 2, 3, 4, 5. It sounds like we have at least 5 slots to fill as it stands. Like if it's just in a row, how do we get it submitted? Sounds like we could have 5 potential submissions with all of us so far. And if anybody else wants to submit too, that may give us more submission slots too. Okay, we'll be following up on this in Slack. I may make a channel about this or find some way to discuss this during the week, because we have to get moving on that. But I know we have limited time in today's meeting as well. So that's good. Anything else you wanted to say about Alife, Bradley, before we kind of
yeah, so I mean, you know, if you want to submit a paper or extended abstract of your own to Alife, you're welcome to do so. So Alife is, I don't know if the link is in the description here or in the Notion, but it's Alife 2023, and they're looking for submissions for like, they actually, I think Jesse posted something in Twitter, I believe, on
yeah,
something from who was that? Tom Froese, who talked about like the theme Ghost in the Machine of this conference, and he had mentioned that it was. Oh, you're going to bring it up, okay? Yeah, he mentioned that it was a nice theme because it kind of gets at this issue of cognition being divorced from the morphology or the evolution of. Yeah, so there it is. So Tom Froese is an embodied cognitive science person. He does a lot of stuff with enactivism. The theme for this year's Alife conference is Ghost in the Machine. And he says, very nice. I think it's about time the field revisits the fundamental assumptions that exiled mind from living systems. So he uses the term living systems, but he means like morphologies and organisms. What were those assumptions, and do we still buy into them? Are there alternatives? And of course, you know, some of the work we've been doing in DevoWorm on we've been doing some things on, you know, the work on DevoWorm is really about development, but it's about the whole organism's development. So developmental biology is generally concerned, modern day developmental biology is concerned with like gene expression patterns and different types of things going on in the body or in the embryo with respect to like you know, biochemistry, and it doesn't necessarily stress the connections as much between like the developing embryo and then what comes down the line with respect to the emergence of brains and the emergence of, you know, behavior. Those things are kind of secondary in the field, and likewise with, you know, in cognitive science, they don't worry about the biology of things too much. They talk a lot about like, you know, the sort of the mind and maybe the brain and how those things, you know, there's always been this assumption of the separate mind and brain, and people have tried to reconcile that in modern cognitive science. So all those things are kind of, sort of flashpoints in these fields. So yeah, this is Alife 2023's website. So I think they're really kind of interested in this topic this year, Ghost in the Machine. And I think I was looking at the submission categories, and the submission categories are generally like in Alife, they do a lot of simulating living systems. They do a lot of simulating, like using genetic algorithms or other types of algorithmic approaches. But there's also a set of philosophy tracks, a set of theoretical tracks. There's also some art track. There's an art track. There's an education track. So yeah, they do have like this this sort of philosophical bent. It's possible to put something in as an extended abstract, which is like 2 pages on maybe like with something with a philosophical flavor, or something with a flavor of you don't have to have these high-end simulations of biology to participate. So if you want to submit a 2-page extended abstract, it's a little late to get into the whole 8-page paper, as I was showing you. This is like 17 pages of like a standard 1-column submission. So that's quite a bit of work, but the 2-page extended abstracts are usually pretty tenable. Yeah, so that's Alife. And then finally, I'll mention that we did get we submitted a paper to the Embodied Intelligence workshop in 2022, the proceedings, and we finally got an acceptance on that. So that was a paper on intelligence offloading in development. And so that was
a little bit ago, or
that was submitted last year. Yeah, that's
when was the alert of acceptance?
The other day, like yesterday.
Oh, okay. Oh, it was this week? Okay.
Yeah, I haven't forwarded it to you yet because I'm not really sure what the action items are on it. So as soon as I figure that out, I'll it's we're getting it worked out. So
great. I'll really quickly. I know time is going by very quickly today.
Yeah.
I'll just share a couple other things in project management land for the time being. So now this is great. These are both in motion now. Cool. Still waiting this for NYCWiC. I'm gonna start. We don't talk about it here, but I'm gonna start basically actually finalizing the Flash talk setup. I think what I'm gonna do is kind of create a macro presentation and kind of like show, like basically make Google Slides and show, okay, here's the layout, and then people can just like insert their presentation into that, because we have different people going. I know Agent was very interested as a new intern, and I'm not sure if they're doing some of the stuff now. Brian's got stuff to do. You've got stuff to do. I've got stuff to do. Oh, I didn't quite know where to mention this, but I'll mention this here, and that what's that?
We all have things to do, Jesse.
Oh, I just put in the chat. We all have things to do.
Yeah. So let's see here. Someone, I don't know if they may be contributing to the NYCWiC presentation itself, but I didn't put it in here. But someone new, I mentioned Slack, someone new may be joining the lab who's going to focus on some of the ethics boards. And I'm kind of looking forward to, whoops, sorry. Well, no, it doesn't matter. Anyway, we may have some new people coming in to finish the NYCWiC celebration out, but we'll be doing more with that shortly. So expect more to be happening with that during the week as well.
Okay.
Yeah, let's see. Anything else that we wanted to cover? Let's see.
All right. Well, I want to get
There's
into
stuff for
some features.
that we can cover, but like we can wait. I don't know what else you wanted to. Did you want to cover anything else specifically today?
Oh yeah,
Bradley?
I want to get into some features and then readings, but I'll do that now. So I just wanted, let's see. So I'm gonna start here. A couple interesting things I found. So the first one is this paper, "Escape from Model Land," and I think this is going to become a book pretty soon. And I don't know when it's being released, but it was interesting. It's kind of a paper on. So in economics, they use a lot of models, and there's a lot of things we can learn from fields that use a lot of models, and thinking about the difference between modeling and like reality. And so this is a discussion paper that sort of predates this book that has the same name, but Erica Thompson is the author of the book. But anyways, the abstract reads, "Both mathematical modeling and simulation methods in general have contributed greatly to understanding, insight, and forecasting in many fields, including macroeconomics. Nevertheless, we must remain careful to distinguish model land and model land qualities from the real world. Decisions taken in the real world are more robust when informed by our best estimates of real world quantities than when optimal model land quantities obtained from imperfect simulations are employed. The authors present a short guide to some of the temptations and pitfalls of model land and some directions towards the exit and 2 ways to escape." So this is the idea that, like in economics specifically, people use models, and there's a temptation, in any field, uh, to use models as sort of a way to sort of get away from reality. In other words, if you're, wanting to build an optimal model of human behavior, for example, it is very tempting to just build that model and say this is the way the mean aspect of human behavior, it's good enough to sort of predict things in the real world. But of course, in the real world, we have all sorts of messiness, and your model is only as good as what you know about the real world. So, on the one hand, models are very good at like describing things as sort of a mean, um, standard that you can then use as information, further information about like empirical findings. On the other hand, if your model is not rooted in reality, then you have a problem. And so this is interesting. The map of model land. This is kind of busy, but basically you have this the kingdom of physical science, the desert of precise physical laws, cliff of faith and convergence and subjectivity. So you have like these cliffs where you have faith that the model will converge. You have this cliff of subjectivity where you think about like some of these issues are related to subjectivity, the sea of self-delusion. You have computation, math, the amusement park of optimal solutions, the confederation of exact sciences. So these are all like speaking to things about like models and how we view them as sort of these physical, and we use physics to sort of instantiate quantitative models, and then they describe the world, but those descriptions can often be incomplete, especially when you're dealing with social systems or other types of complex systems that have a lot of you have good model-based decision support in different fields, but in other fields we don't really have that. So it depends on the field you're in. So that's interesting. I think this is kind of laying out the pitfalls of model building and relying on models too much and their interface with the real world and empirical data. So I'll make that paper available to people if you want to get more deeply into it and understand some of these issues. Then you're welcome to do so. The other thing, another feature here is this article on investing 5% of research funds in ensuring data are reusable. So we don't talk too much of, well, I mean, this is a thing that we talk about in some of our open source work, is this idea of open access and open data. And one of the fundamental challenges in science, and reproducible science, but also in sort of this open data movement, is in getting people to engage in sharing their data sets. And indeed, it's not as easy as just a behavioral change to say that I'm going to be altruistic. It's actually quite a large investment in time and in money, because you have to take your data that you've collected and you have to format it according to certain standards. And but also even taking a step back further, you have to collect your data in a way that's consistent with certain standards. So you want to make sure that you have a data set that represents reproducible things that reflect the real world in a systematic way. And then you want to be able to take those data and format them in a way that people can access and use. So we talked about the FAIR standards before, which is findable, accessible, interoperable, and reproducible. That's one of the features of data sharing and data availability, is making them conform to those standards. And then this is a Nature Perspectives article. They basically want to support data stewardship as part of the research enterprise. So they're advocating for investing 5% of research funds in ensuring data are reusable. And so this goes from planning your data collection to data collection itself to actually putting in an infrastructure to make it available to people, and then ensuring that people reuse it in an ethical way. So, this is an ethical duty to take, for data stewardship, to, make sure that the data is, clean, accessible, available at every step, and that people can reuse it. Because we do spend a lot of money generating data. We actually spend a lot of our research money, in the funds, we spend it on research, but then what's the output of that research? Well, you have papers, of course, but you also have data. And so if we don't make the data available, if we can't rely on the data, then we only get about half of our money's worth. So investing 5% of research funds is actually maybe a modest proposal. So I'll make that available again for later viewing. So then I wanted to talk a little bit about XEROX Park, which was it was a research institute that Xerox sponsored. So it was a private industry research institute that they founded in about 1970, maybe in the late 60s. And they, this was one of the places that generated a lot of the advances in usability. And so this is an article from IEEE Spectrum on talking about Xerox Park and its engineering prowess, how they invented the future and then how they lost it. So this is the Palo Alto Research Center, Xerox's Palo Alto Research Center. This is a picture from, I don't know what year this is, but this was where Park was located. And so in late 1969, they were going to develop the architecture of information to solve problems that have been created by the knowledge explosion. And so they're basically, at the time Xerox bought Scientific Data Systems, was a mainframe computer manufacturer. Now that we're in the digital computer business, we better damn well have a research laboratory. So they built the Park Research Laboratory. And, this is kind of like, compared at the time to Bell Laboratories that AT&T was running. They had a lot more researchers, of course. But this is, something where they were able to build a lot of these things that we now take for granted, such as the mouse for, based on the Macintosh design, the mouse and overlapping windows in the graphical user interface. colorful weather maps on TV news programs, laser printers, structured VLSI design, networks that link personal computers and offices, semiconductor lasers that can read and write optical discs, so like CD-ROM writing, CDRW technology, and then structured programming languages like Modula 2 and Ada. So they were at sort of the cutting edge of this research, and they were doing a lot of really interesting things, especially with respect to user interfaces, which is interesting because by the mid-1970s, close to half of the top 100 computer scientists in the world were working at Park. And so they employed a lot of big names back then, people like Alan Kay, for example. And so this is something that was going on at a very high level in the 70s. And then eventually, of course, it fell by the wayside. This is the nice little visualization of the history of Xerox Park. So they planted this tree in 1970, and then you get all these branches that come out in the leaves. So in the leaves, you have all these different things, like Apple's Lisa, which was an early version of an Apple computer, Apple Macintosh, the GEM operating system, the computer mouse, an early version of a touch tablet, then some things having to do with fabrication and silicon compilers, VLSI design, different types of modular computer languages, interlisp, video art. Lucasfilm's Pixar actually grew out of the Park Labs to some extent. Some internet standards, and so on. So they had a lot of things that came out of this enterprise, and I just find it fascinating from the standpoint, and then these were the origins. Actually, there were a lot of origins at the University of Utah, at the Massachusetts Institute of Technology, the Lincoln Labs, which are at MIT as well, and Digital Equipment Corporation. So you have all these organizations that kind of come together in the formation of this institute, and then you get all of this stuff coming out of it. Jesse.
Oh, I was going to pose a question. Was Atari there too?
I don't think so.
I think Atari and Xerox might have been separate companies.
Yeah, they were. But I mean, I don't know if they had any ties to Atari. They probably exchanged people at some level, but
yeah, I think. They definitely exchanged people. Yeah.
So yeah, I find this just fascinating from the standpoint of like the development of some of these technologies, and so this is a really long article. It kind of gets into some of these innovations that they made. There's Alan Kay. He worked on Smalltalk, which was to create these overlapping windows in a graphical user interface. Actually, Alan Kay, after spending 10 years at Park, he became the chief scientist at Atari. And then he moved to Apple after Atari.
Oh, there we go.
There we go.
I always get some of them like almost mixed up, like not just like with which came first, but how specifically they were tied with one another. Because I understand they would like work together. There would be affiliations. There would be like shared trademarks and groups together. Like for example, like Pixar, right? We associate that with Disney, but it's not Disney. Disney and Pixar are they're like together, but they're two different different entities. Just as an example, right? Yeah.
So okay. Amanda had to go. Thank you for attending. We won't get time to get into it, but we've made a lot of progress in shaping some of cognition futures.
Yeah, there's a bunch of leadership futures updates that aren't being mentioned today. So I won't have time to get into them either because I'm gonna go soon. But yeah.
So I wanted to actually. So that's all I wanted to talk about with respect to that. I had some other. I think that was it. I just had this larger version of this figure, so I can make that available. And then I think I wanted to get into these papers on. So last week we talked about this Dendrify paper and Dendrocentric learning, and then today I wanted to follow up on that with some other papers I found. And so this is something that we can follow up on later, but it's just, I think it's a really interesting area. So there's this, we talked about, synapses and the role of synapses in computation. That a typical neural network, you just have these, cells or these units, and then they're connected by some sort of correlation or some sort of co-occurrence. There are different ways you can characterize the connections. There's usually some strength of connection. But in actual neural systems, you have these synapses that have a lot of things going on at them, and so you can use that synaptic activity or the diversity there to sort of get at some detail or some depth in the learning process. And so this is a review of synergistic learning. This is a paper by Chenguang Li and Yu Li. They're from China, and they did a review on this area. So the abstract reads, in neuroscience, it is widely believed that learning and memory are primarily based on synaptic plasticity, which is a neural mechanism that modifies the strength of connections between neurons. As a counterpart in machine learning, the modification of connection strength or weight endows artificial neural networks with a powerful learning capability to solve various problems. So we mentioned that already. And the difference, of course, is that synaptic plasticity is much more sort of detailed than this sort of thing we use in artificial neural networks. Independent of modification for synaptic strength, recent experimental results have revealed that a single neuron also has the ability to change its intrinsic excitability to fit the synaptic input. This mechanism is referred to as neuronal intrinsic plasticity, or IP, in the literature. So this is kind of I guess it's a feedback that we have that we don't really model in, again, our model land. We don't really account for it. Computational learning rules for IP have been developed based on hypothesis of information maximization with a stable response level. With the discovery of this novel plasticity mechanism, a series of studies have focused on how IP plays a role in biological neural systems and how they benefit the learning performance of artificial neural networks. In this review, corresponding research on synergies between IP and synaptic plasticity mechanisms is presented in both the computational modeling of biological neural systems and the applications of artificial neural networks. And this combination in artificial learning systems is defined as synergistic learning. So this is, again, the idea that we're using the synaptic plasticity and this neuronal intrinsic plasticity as a specific type of learning that we can then sort of model and get incorporated into artificial neural networks. So a series of synaptic plasticity theories were proposed before relevant experiments were conducted to provide biological evidence. So this is the weight updating rules for synaptic plasticity are here, where you have the weight of a synapse linked from a presynaptic neuron to a postsynaptic neuron, and the modification term, which is this change in this weight. So this is the weight change from two time points that are adjacent. So you can think of this as Hebbian learning, but there are other other ways to think about it. But Hebbian learning theory claims that neurons fire together and wire together, which is a common term that people use. It's actually not attributable to Hebb, but that's the term that we use. So there's basically this association. And so this, biologically, this is much more complex than what we usually get in an artificial model. The Hebbian rule is in essence unstable, and the synaptic strength will be growing in an uncontrolled manner. So if we think of this in a linear sense, just simply saying that two neurons are associated by activity, that's great if you're just dealing with the two neurons, but in a large array of neurons, this can be uncontrolled and unstable. So there are different ways you can update the Hebbian rule, and they go into that math as well. So they're kind of going through the synaptic plasticity rules, going through some of these other learning rules, and then they go through 5 important synaptic learning rules, which is the Hebbian rule, the OJA rule, the BCM rule, the SDDP rule and this CADP rule. So these are just different rules that they go through here. Some of them involve spike timing, which is something that's generated by a neuron when it generates an action potential. Some of them are based on, causality. Some of them are based on rate coding, which is something that happens over time. You get a rate and there's a code that exists there. So there are different ways that you can model this. So it's very much, beyond that simple correlation between two units. And there's this whole field of spiking neural networks, which we won't get into, but is sort of separate from, it's sort of a subset of neural networks. And, you can learn more about that at NeuroMatch. I'm not going to get into that. But this, kind of gets you into the machine learning aspect where you can then put these into machine learning models. There are different models like self-organized maps or Grohonen maps, which actually allow you to represent some of these things in a space. And then they get into, intrinsic plasticity, which is where you get these, the plasticity of specific neurons and, accounting for its synaptic inputs and, maintaining this homeostatic, stable state. So this is something that we have to think about as well when we model synapses, synaptic activity. So this is, they go through that some more, and they kind of get down to their, so they're advocating for this position, and they're kind of laying out all this evidence. This is a very long paper, actually. But they're advocating for this position of synergistic learning, which is where, we look at the synaptic plasticity, we make all these considerations, and then we can talk about synergistic learning, where we're kind of combining all these things into a strategy for learning. So that's synergistic learning. Then there are these other two papers on how synaptic gradient, well, the first paper is synaptic gradients transform object location to action. And this paper, it goes over sort of taking some of the synaptic learning and transferring it into different behaviors. So the abstract of this paper, this is synaptic gradients transform object location to action. The abstract reads, to survive, animals must convert sensory information into appropriate behaviors. Vision is a common sense for locating ethologically relevant stimuli. That means if in animal behavior, there's stimuli that are relevant to the animal. And then guiding motor responses. So this is our typical, sensory motor loop where you're seeing things in the environment, you're responding to them with motor actions. So you see a predator, you run. You see a piece of fruit, you reach for it, that sort of thing. How circuitry converts object location into retinal coordinates to movement direction and body coordinates. So this means that you have coordinates in your retina. Things fall in your retina in a certain location in space. Those coordinates then are transformed into body coordinates. So you have to, in order to move, you need to take things from the retina, say it's on the left-hand side, and transform that into body coordinates so that your left arm will make the proper movement, or your right arm will move left. So you need to know kind of where things are in space, but then your body needs to be able to match that with a separate coordinate system. So no one's really been able to figure out how that conversion works. I mean, people have hypothesized how that might work, but it's not something that is not well known. Here we show through behavior, physiology, anatomy, and connectomics, which is the study of brain interactions between neurons, connections between neurons. And this is done in Drosophila, which is a model organism. That visual motor transformation occurs by conversion of topographic maps formed by the dendrites of feature detecting visual projection neurons, or VPNs, into synaptic weight gradients of VPN outputs onto central brain neurons. So this is done largely through, largely through synaptic learning. We demonstrate how this gradient motif transforms the anterior-posterior location of a visual looming stimulus in the fly's directional escape. So a looming stimulus is something that sits out on the edge of the visual field and moves inward. So it looms. And then, so the stimulus is in the fly's directional escape path. So the fly will have an escape mechanism where they escape some stimulus because they see it coming as a threat and they want to move. Specifically, we discover that two neurons postsynaptic to a looming responsive VPN type promote opposite takeoff directions. So they have to move in one direction or another away from the stimulus. So what this means is that there are two neurons postsynaptic to this VPN type. So that means they're downstream from the VPN type that promote the behavior of taking off in one direction versus another direction. So this is kind of isolating it to a specific set of neurons. And you can do this in insects because their brains are such as that they have certain nuclei and certain neurons that do certain things. It's kind of like C. elegans in that way. You don't have that as much in the mammalian brain, but this is a good model system for this. Opposite synaptic wake gradients onto these neurons from looming VPNs in different visual field regions convert localized looming threats, meaning this visual stimulus that's seen as a threat to the fruit fly, into correctly oriented escapes. So they have to be able to move in the right direction and get far enough away from that threat as possible to survive. So they have these mechanisms that are, I guess they're evolved, that allow them to survive. And so they're actually, automatic movements. I mean, if you looked at the fly, they know exactly where to go. Well, this is the sort of the neural substrate of this. For a second looming responsive VPN type, we demonstrated gradient responses along the dorsal ventral axis, which is top to bottom. So this is like from top to bottom of the fly's world. We show that the synaptic gradient motif generalizes across all 20 primary VPN cell types and most often arises without VPN axon topography. This is within the brain. So this, the dorsal ventral axis would be from the head of the fly to the belly of the fly, or and then this is actually in the brain where you're getting these graded responses. So this most often arises without VPN axon topography. Synaptic gradients may thus be a general mechanism for conveying spatial features of sensory information into directed motor outputs. So you have this spatial map coming into the retina, into the insect eye, which is the compound eye. It's coming into the brain, and it's coming in this sort of map. Then that's distributed across, different cells and dendrites, and then it comes into these two cells as synaptic inputs, and then that drives the output behavior, the motor behavior. So this is an interesting paper. It gives you this very nice system to work with, gives you this very simple system to work with, and it really kind of shows how these things can be mapped from sensation to behavior. This last paper then I'll talk about is this sort of the news and views version of this paper. So this is going to be a more easily digestible version of what we just talked about. So this is called a neural strategy for directional behavior. How does a fruit fly's brain determine which way the animal should escape in the face of a looming predator? A mechanism involving numeric gradients of synaptic connections between neurons provides an answer. And so, eyes are essentially for revealing details that would otherwise stay hidden. Even quiet or odorless objects cannot usually avoid interacting with light. The brain then uses this information to identify where an object is and decide whether it's a desirable or repellent thing, ultimately transforming the visual patterns into the muscle activations that define a behavioral response. So then this is a topographic representation, a visual space that the brain uses to sort of make this decision. But we have to know what the neural circuitry is. So, this paper that we just talked about describes this pattern of neural connectivity that accounts for such transformations. It allows fruit flies to escape looming visual threats. And so this might be a common mechanism, or it might be just applicable to fruit flies. But we use fruit flies because they are actually relatively simple systems that seem to map well to other organisms. So yeah, they kind of go into what fruit flies are useful for. When a resting fly sees an object approach, a predator, for instance, it takes off in a sensible direction, backwards if the object is looming in front of the fly, or forwards if it is behind the fly. The retina conveys the position of the looming object through columnar neurons, and then there's this signal that gets sent to other neurons. This is passed to the VPNs and the third optic neuropil, and then you get the dendrites of each LC4 cell, which is downstream or in VPN. These are looming sensitive VPN cells. There are roughly 70 in each half of the brain, so on the left side and the right side. These gather information from a small visual area called the receptive field, which is this area, the central area of the visual field. And so then this information then is mapped to these takeoff cells that sort of get activated at a certain point when the looming stimulus is close enough and the fly takes off. So that's the decoding object position encoding. So this is an example here of backwards takeoff. You get this these LC4 cells. They're sending information down to the synapses here. And then there's this takeoff signal, either don't take off or take off, depending on how they're, what's activated. And in the forward takeoff scenario, you have an opposite architecture here, where you have the signal sent through synaptic communication. So you can see that there are multiple synapses and there's a summation of things going on that give this decision signal. So I see that Jesse had to leave.
It's just me.
Yeah,
Okay,
got to
well,
drop off for some
you.
other things. Okay. Well, yeah, thanks for sticking around. Yeah. Any questions?
Okay.
Sounds good. All right.
Thanks.
Thanks for attending. See you next week.